Mike Lockwood's coming up here, wanted to talk, so I don't want to delay him at all. All right, so you should have, your operation should be done, all right? And you should have some data on your screen down here under the table. It should have a bunch of files listed. Those are the ones that actually looked at and came up with some statistics.
Gotta see me.
All right. Does everybody have that? You're still working? How slow is that? I thought I had the slowest computer.
It was pacing yours the last time. Now this time it's behind.
Oh, well, let's see.
Star detector 1.25.
Yeah, that's just what it's doing. Wow.
Yeah, before
It's still running, though. It's still
I
going.
know, it's still running. Like I said, before they were matching each other in speed, but this time it's slow.
Which one is it on? It's
Dynamics, global.
No, I'm just looking at which file. Calibrated, number 2947. So, all right. So is anybody else still crunching data? That what it is? Well, I guess I don't have the slowest computer.
You can blame me. I don't like getting blamed for stuff. It's good.
All right. Well, I'll talk about this twice. So for the people that it has completed for them, you're going to see some data here of the files that it processed here, and what I'm going to do here, I'm going to stretch this window out a little bit more. It's dynamically movable and stretchable and stuff, and I'm going to close this screen. I guess I can't close it because it's a script, so it doesn't matter. But what I'm going to do here is I don't need to look at these subframes anymore. I know they're there, so I'm going to close that window to give me some more screen space. And I'm going to click on plots. Okay. So what it should have come up with on yours, if you click on plots, this full width half max should be defaulted there. So that is a running graph of all those images of the full width half max. Okay. If you have spent any amount of time processing information, doing things like statistical rejection, using things like sigma combine or sigma rejection algorithms. Normally, for most good sets of data, if you reject everything outside of 2 sigmas from the mean, you're pretty safe. The reason why that's important is because over here, what it does, it gives you the standard deviation of that data set, okay? Probably from the low to the high. It automatically creates the range. In this case, it's from -2 to +3 standard deviations. Personally, if I get a whole bunch of information, I automatically get rid of anything that's above 2 standard deviations because I want the stuff to be very consistent. So it computed the mean, and the mean is somewhere down in here from all this data. But you can see the full width half max goes from like 1.8 here, and it goes down to like 1.6. It's not a big range. And then up this image here is 2.3 or something. You know, I refocus every half a degree change. Probably the focus changed a little bit between images, and this isn't a whole lot. But if you have a lot of data, things that are bad really stick out like a sore thumb. So what I'm trying to do here is I'm using this to decide ultimately what data I'm going to stack. So I want to get rid of this one because it's above 2 standard deviations. That's just John Talbot's way of doing it. For you, it may be 3 standard deviations.
To note that that number comes in later on down the process road.
Well, it does, yeah.
That's why this is important to know.
Yeah. I wasn't, I have a kind of a technical, my my thing in life I did was a meteorologist. So I've got a lot of math background. A lot of people don't necessarily have a lot of math and may not understand, what that really means when you talk about standard deviation. Richard, you're a really smart math guy. Is there a layman's term for kind of what?
Deviation?
Yeah.
So if you have a bunch of people that are like from 6 inches tall to 6 feet tall, you take the average, and you're like, well, the average height is like 3 feet. It doesn't really tell you how much the variation is between people. The standard deviation gives you a better idea of what the typical, how tall people are typically. It's a better estimation of that than the average. It tells you how much you vary from the average. How's that?
Yeah, so in the big scheme of things, I don't want to include images that are non-typical. Something typically is wrong with those images. And for me, it's 2. For most situations. Some situations it may be 3. In this case, just for grins here, we're going to say 2. So in order to reject this image, I just click on the dot here. See the dot right there? And it puts a little X over it. And up here in the table, it's automatically unchecked that image. All right. But this is only one thing we're looking at.
And this is resolution, right?
This is full width half max. This is basically
Type of images are.
how well it's looking at how well defined your stars are in the image. Usually when you're in focus, you have a much smaller full width half max than if you're out of focus. If you're way out of focus, it's a big number normally. If you're in focus, it's a small number. It depends a little bit on your focal length of your scope and your resolution of your imaging system.
There's a trade-off. If you wanted to remove the first frame because it's almost 2 sigma, you might have a slightly cleaner, tighter,
Right.
a little more noise.
So in the end, since we're going to stack all these images, maybe I wanted to get rid of this one too, because maybe I want to keep all my data as good as possible, and I only want to stack the good stuff, and I want to throw out. Visually, however, when you have a lot of images, I'll see a lot of it, it'll go up and down. But I will see ones that are outside the mean, and for me, it's the number 2. And what I do is I physically take a piece of paper up to my screen, and I go like this. All right, there's 2, all right, that one's gone, this one's gone, this one's gone. Maybe for you, it's just visually looking at it. You can just click on them. But this is only one value here. This is full width half max. If you click here, it gives you a whole bunch of other things you can plot. The next thing I look at is the eccentricity. And what that is this is how round your stars are. And look, there's one that sticks out like a sore thumb above the mean of all the rest. Well, something must be wrong with that one. So I'll go over here and I'll click on that one. I don't like that. That's all the rest of them are right around 0.45. But this one's 0.65. Well, maybe a gust of wind hit my mount, or I don't know, something. The guider messed up if I was guiding or whatever. And then I look at the last one I really look at, which I think is the other most important of all this stuff here, is the median of the image. All right. Remember we had 2 clouds in it?
Those are there.
Look at the ones that are high up right here. So this is the value in ADUs of the background of the whole image. It's the median of the whole image. And you can see most of them are all the same except those 2. Well, those are the 2 with the clouds.
So you get rid of those.
So I get rid of those.
Those 5
All right.
images we just knew.
I click on those, all right? And it looks like there's a couple other ones that were actually, they're cloud-free. These are the other ones I clicked on, earlier. So I'm left with all the rest. I got rid of four images here, right? And, or 5. 1, 2, well, I got rid of 4.
5.
5, yeah, you're right, 5. If I click on weight, what it does is it automatically weights the image based on the signal-to-noise ratio that it computes. Usually you want to have your master image that you stack all the rest of them to. You want to use the one with the highest signal-to-noise ratio. In this case, and you want to typically, if you have luminance, red, green, blue type of data, maybe you took your color bin 2 by 2, you took your luminance bin 1 by 1, you typically want to use the best luminance and stack everything, register every other image to that one. If they're all the same binning, it really doesn't matter. You pick which one you want to use, but this gives me an idea of visually, easily, which ones are good and bad. And you can see the weight of most all of these is the same. But I'll go through those and I'll say, up there on the top, it automatically sorted the data based on weight. And you'll see this has the highest weight of any image that's still selected here. So maybe this is the one that I would use to register everything else to. And if you can't see it there, this is kind of like Excel. You can move this window open a little bit and you can see what number, and I'll write that down. That's my main image that I'm going to use to stack all the rest of them too. You can't read this up here? 2944. But I already, what we're going to be working on tomorrow is information that's already been stacked and mastered. It's not necessarily going to be that one, but that's how I would go about selecting the right one. All right. So this gives me a good approximation of all the good data here, and you can either click on the check mark over on the side to select one, or select it or deselect it. You can click on the little circles, buttons, which these numbers here correspond to the order they're in up here. Let's see. I'm sorry. This is corresponded to the weight that it gave the image. And you say, well, why did you get rid of those two that have a higher weight than these? Well, those two I know have clouds in them, okay? And I figured that out by one, visually blinking the data, and number two, by looking at the median of all the information, and those two were way up there high. So I know I don't want to use those, and these weights are kind of out of the mean of the rest anyways, so something else was going on there. And I just knew it was bad information, and we want to get rid of it. All right, so we've selected all our good images, right? So now, just go down here. I need some more space, so I just close that window, and I click on this little output window here. Not output subframe button. Don't click there yet. Click on this little window here. All right? And this pulls up another window, and here in the approved action, you want to select move, because what we're going to do is we're going to automatically save out our good files and save out our bad ones, and they're going to go two different places. So I select move, and then under the approved directory, all you have to do is click there and call it something, create a directory. I would click like new folder. Say I'm going to put it in the root, which was. Well, you should be able to, if you right click in there in Windows, you should be able to create a new folder. So
Don't forget, guys, this is on a Mac, so when you go to the operating system dialogues, it's going to look a little bit different than yours.
right. So what you're going to want to do is create a new folder, okay? I call mine approved. I want a new folder called approved, and I create another one called rejected. So in this case on a Mac, I just select new folder and I say approved. Whoops. All right, and I hit create, open, and what it does is it tells the program I'm going to put all my good files in this approved folder, and it's going to add a postfix letter of A to it, which means it's an approved image. And then under the rejected directory here, you do the same thing. You click over here, create a new folder called maybe rejected or whatever you want to call it. Select that folder, and all your bad images are going to go there, and it's going to put an X on those, that it's going to append an X to them saying, hey, these are bad images. Kind of a way you can keep track of them. And this is kind of a advanced topic of PixInsight. You don't have to go through this, but it's, you can just use the blink method, but this is a really good way to visually look at your data if you have a bunch of it. And bad ones stand out like a sore thumb. That's why I'm going through this. All right, so sir? Yes, move for both. All right. Okay, when you're done with that, all you have to do is hit, let's see here, I got to create my rejected one. So, okay. So once I'm done, down here I hit output subframes. All right? And it's going to automatically move those files into the right directories. All the good ones, the approved directory, and the bad ones, the rejected. All right? So I would do that with every, we're not going to go through the luminance and all the rest, but I wanted to show you what a bad image looks like, and I knew those two had clouds. So I would go through my luminance, my greens, my blues, my HAs, and I would do that same process. And it takes a while, but it's a very good way to sort your information out if you have some good information and some bad information.
Eventually, you just totally delete your.
Yeah, eventually I just may go to that rejected folder and just get rid of it because I know those files are bad.
The folders are clean.
The approved ones are good ones.
No, but I mean the folders that you took these from are clean.
Oh yeah, the data's been moved out of those folders. Yep. All right, so
you use blink first and then you...
I use blink first to visually look at stuff, and then I go to subframe selector and I do a little bit more rigorous,
and after you've eliminated the ones that you visually eliminated with blink. Right?
Well, I just wrote those, in my case I wrote those down. You can physically move them within blink also, but I'd rather move the files one time, and I do it in subframe selector. Okay. So, the last thing I'm going to say about this is this allows you to look at all the other information that it collects on each one of these images here. This is scrollable, and you can, if you want to, spend some time looking at that stuff, you can. It's all there. You can sort these based on, right here, you can sort it based on, it defaults to weight, but you can sort it by name. You can sort it by full width, half max. It gives you lots of different options on how you can, get the data arranged for your eyes. It's really easy to do. All right, so that's subframe selector.
Is there a way to replay the measure after you've done this selection process to see the new statistics?
I don't think it caches.
Your selection criteria for the...
Oh yeah, so if I close subframe selector now, and I just go dismiss, all right, and I open it again, it gets rid of this stuff, but it remembers the files I put in there the last time I had them open.
Okay, but it hasn't erased any of
it. It erased all this information
but
here.
It hasn't recorded your selection.
No.
I'm wondering if you can replay the measure.
It probably writes it to the log file.
So it's not something that...
Yeah, I'm not really sure. I never really went to look for it, to be honest with you, but I don't know if it... Okay, so here under the process console, it recorded where they went. So
you could go to the saved folder and do it on that, where you put the ones you accepted.
Well, they're already there. Yeah, it moved them there.
So you could do the measure on that to get the statistics on.
Well, you could, but I've already done it. I don't need to do it again.
Why do you want to
Why do I want to redo?
on the same data set?
If the selection criteria that you were using on a plot was very close across a bunch of different frames, and you were going to be totally anal about the one that you chose, you might want to expand that out.
And it will do
It
that.
would give you the same value. That sigma value still tells you what the outlier is.
Yeah, it does, and you'd have a new average, and you'd have the expanded view of the sigma.
Yeah, it'll expand the graph out for
Probably
sure.
Get rid of data you should keep, because when it gets to stacking, it stacks based on the weight of the
Right.
nodes and stuff too.
Yeah.
So unless the data is really bad, you probably want to keep it anyway.
Yeah, yeah. Mhm. Okay, so before, well, it saved those files to those other directories.
I haven't output subframes or
Oh,
anything.
select there, hit output subframes.
Yes.
So we can accept this.
Done. Yeah, you can close that. If you hit the output subframe button, you can close that window. And if you want to look, you can open up those folders. You should see those files. And your rejected folder should have two or three, and your approved folder should have some images in there. All right. Yes, sir.
System parameters, I tried to copy that off. No, what was the first parameter was the selection?
Okay.
How do I see those again? Not in the subframe selector.
You could get there, but you'd have to go to the...
So 3.2 arc seconds per pixel. The first one, and that was the camera gain. Yes, these are specific to your setup. This number, arc seconds per pixel, is fairly easy to figure out. There's calculators that'll do that. There's actually calculators that'll do the gain. There's several ways to compute the gain of your camera. Easiest thing is just go to the manufacturer's website, look at what they say they set it at. It's pretty close. QSI would tell me they set it at 0.5. When I measured it, it's really 0.472. But does that make that much of a difference when I run it here? No, it's not going to make that much of a difference. So however you decide to figure out what that gain is, that's the number that you stick in there.
Is that going to be different for DSLR versus CCD?
Yes, it's different for every...
But I mean, that information is still available under those circumstances?
Yeah, you can go to, I can Google what's the gain on a typical Canon 60DA, and I can find it.
Sensorgen.info has every Canon camera listed.
There you go.
The gain varies based on your ISO setting. So you look up your camera, your Canon camera, you look up your ISO setting, and it'll give you the gain. Sensorgen.info. Sensorgen.info. Yeah.
I'm going to write that one down. I didn't know that one.
Not Nikon, just Canon.
They may have some Nikons, but I don't know because I don't care about Nikon. But I remember because
Tell us how you really
I've
feel.
got tons of Canon cameras, so that's where I always go. But they probably have some other cameras, but I can't say authoritatively because I've never looked up the Nikon game. But I have looked it up for Canon cameras.
Okay.
Yeah, .info.
All right, so
For sale.
what we're going to do now is we've got our good frames, ones we're going to register and stack. So the next thing we got to do is we need to register our images, right? Align them all to a base image or a master, our best image. So under the Process Explorer here,
I lost my Process Explorer. How do I put it back on that column?
okay, you got rid of yours. So go under here, I think under View, Explore, Windows, and click on Process Explorer. It should pop it back in.
Yeah, thank you.
Yeah. Okay, so I think under this is not going to be under favorites. So down here along the side there is a tab called Image Registration. All right. And if you click on that, it gives you three different options. We're not going to get into comet alignment, but there's a way that you can register images of a comet that you took, because the comets moving in relationship to the stars. So it's a little bit You can read about it, but we're not going to use that. What we want is star alignment. Star alignment is the double click there, and it's going to open up a window called star alignment. All right? This is the app within PixInsight that registers all your data. And to start this, we need to select what our best image was. And the one we decided we're going to register all the rest of them to. So over here, click this little drop-down button and select File. It defaults for some reason to View. I don't know why, but
Have it opened already.
yeah, you may already have the image open, but I select File. And then right next to that, there's another button, little arrow down. Select there, and it'll open up a folder. And you're going to have to navigate yourself to that approved folder. And
Which one was it?
okay, so in the real world, you're going to have a whole bunch of data here, all your filtered information, everything, your reds, greens, blues, lumens. In this case, we have just a really small subset, but that's okay. So we're going to say that this number, this top one here, or number 2947 is the best one. That's the one I'm going to register all the rest of the images to. Just remember, in the real world, it's going to be whatever, maybe your luminance. You make that call. But here, we're just going to select this one. So highlight that, and select Open, and it's going to write that image up into the top up there. So that's the base image. It's going to say, I'm going to align everything to that. This stuff here, it should default to projective transform and register match images, and nothing should be checked.
Hey, John?
Yeah.
Most people do not have their image, so rather than me helping almost everybody, can you go over that again? The reference image.
Okay, yeah. So under, right next to the file box, there's another drop-down arrow, an arrow there. If you select that, it opens up. It allows you to access any folder you want on your computer to select the image. So go to your approved directory. It doesn't?
I went ahead and... Yeah,
Click
and
there.
I did that.
Okay.
And I
Yeah.
clicked on that.
Right.
And I clicked Open.
Okay, and there it is. It's there.
Oh, okay, I thought it was going to...
No, it doesn't open the image. It just puts the file name in the top of that application.
You can also double-click any of the files that are in your list, and it opens them up automatically, and then you can select it as
Well, yeah, you can do it that way. Yeah, yeah. Okay, has anybody not selected the base image?
Yeah, mine's put it in target images. I don't know what's going on here.
Okay, Richard's got you. Okay, so the next thing we want to do is nothing should be checked, okay? Projective transform should be listed here, register match images here. There's other options here for lots of other things that you can do. However, what we want to do is we're just going to register match, and that's all we want, okay?
Which is fine, but I've noticed like sometimes I'll have to use 2D spline instead of projective transformation. When I take images, like say if I take an image in summer and one in winter or something like that, you know, several months apart, temperature is very drastically different. There might be a slight scale change of the image.
True.
That's where you want to use 2D spline. It takes a little longer, but man, it works.
But 99% of the time, this works just fine. If for some reason your images don't match up right, there are other options within PixInsight, but for this class experience, we're just going to use the register match ones. You can read all about the other options, you know, at your convenience and what they do. So, ready, Neil? All right, so down here along the side, there's an Add File button, okay? Everybody got that? Click Add Files. It should go back to that same directory. All right, select all of them.
Including your...
All of them. Yep. And hit Open. Okay? It's going to load those in, and these are the files that it's going to register to that master one at the top. And if you noticed, I've 2947 is already up there, and it's down here also, but it doesn't matter. When it goes to register, it's just not going to do anything to the image. It's just easier if you just select, it's much quicker if you just select them all, instead of having to figure out, because when it writes the output, registered images, it's going to write all of them to a registered file. If you don't select your master image, it'll leave that one behind, and you're going to have to go grab it and move it later if you want it. So it's easier if you just select them all.
Are you just doing one filter at a time?
In this case, we are, but like I was mentioning earlier, probably in my case, I would use maybe my luminance image as the master, one of my best luminance. I'd register all the images to that.
And you're adding...
And I would select all of the images in my approved file, include all the filtered images, red, greens, blues, and they'd all be listed in here. You know, there could be 100 of them, but they're all listed in there. It's going to register every one of those files to that master image, all at the same time.
So you don't have to segregate two separate.
Yes, you can put them all in there. All right? Okay. So the first thing you have to do is tell it where to put it. So here you select where do you want to put those files, all right? And you click on the little file button over on the side, and what I'm going to do is I'm going to create another new folder. I'm going to call it just Reg. You know, that's the I know that name is, this is where all my registered images are. You can call it whatever you want. But create the folder where you want to put all these registered images. Hit create. And open, and it gets written down here in the box. Okay? And it also automatically fills in some information here. Don't just leave those as default. Don't worry about them.
Yeah, mine said rejected registered too, not under.
Well, that's because you have to create a new folder under your root directory. Wherever you want it, you just created that under registered. That's an operating system thing. You can call it whatever you want, but I call my folder registered, just because I know that's where all my registered files are. It's just easy for me to remember that. You may want to call it Denise. I don't, you know.
Call mine aligned.
Aligned. Yeah, something. Okay, so as we continue on down here, leave this stuff as default. Under star detection, if you want, we're going to leave that default, so I wouldn't even mess with it. But what I would mess with is under interpolation here. If you click that button here on the right-hand side of interpolation, it opens up another little window. Now, this is more a personal preference. PixInsight will automatically use what it thinks is the best algorithm to register and rewrite those images, rewrite the entire pixel array. And it uses, it's got several different ways to do it. Bilinear, nearest neighbor, bicubic spline, bicubic B-spline. If you really don't have to be familiar with what all those do. If you want to read about them, you can. You can mouse over and it'll tell you what they all do. My personal experience using almost every system I've ever shot through is to select this algorithm called bicubic spline. Okay? If you want to leave it auto, it'll do a fine job. That's okay. But what you should always change, I find this is too restrictive, is this clamping thing they call clamping threshold. It's an internal algorithm that when you move an entire array of pixels, it has to rewrite them. And do you know mathematically what it really does? I don't know, but through a lot of trial and error, I do know I always have to change that, and the value I use is 0.1. If I don't use 0.1, I typically get artifacts around my registered images. I look at my registered images after it's done. I'd see little black dots sometimes near the edge of stars. It has something to do when it rewrites that entire pixel array to shift, say, this image over on top of this one by 3 or 4 pixels this way, 5 pixels that way. Sometimes when it outputs that image, it creates some artifacts, and they explain some of that in the mouse over there. But I've just found through a lot of trial and error, and you may want to write this down, and you can test this for yourself, typically bicubic spline and 0.1 works on everything I've ever processed just fine.
What about auto?
Auto is okay, but I would change the clamping threshold to 0.1 anyways. And I think the only, if you have a very long focal length, very big, like a 20, if you have a 20-inch RC type scope with very, very well-sampled data, auto and its default settings probably work okay. If you're shooting a little bit undersampled, or, you know, which I typically do because I'm shooting a lot of wide field stuff, and you have to change that number. But 0.1 always works for me, whether I'm oversampled or undersampled. It works perfect. So I would change that. And that would be my tip of the day. Write that down, just remember that. Put 0.1 in there, okay?
Good question. Does it tell you when you use auto what it actually uses?
Yes, you can look at it later. So once all that's done, the Pixis Insight Global button here, which is the little globe, all right? If you click on the apply button, which is the square, it won't work. If you click on the arrow, it's not going to do anything. Click on the global button, okay? So now what it's going to do is it's going to register all those images. And go ahead and do that on yours. Let it do its thing.
Take a while on slow machines.
There's only 7 images, so.
So does the clicking global, does that save the interpolation parameters for future use so that we don't have to write it down?
No, clicking global is the only way the application works. And I didn't go over this in the early stages. The square button is for a local process of something that's already on your screen. The global button is for a process that computes on a whole bunch of data that's out there on your computer, I guess is the easiest way to.
Okay, so I misinterpreted what global means. So global doesn't change that parameter setting
No.
for the
No.
entire future?
No.
Okay.
You're done.
All right, so we're done. Hopefully everybody else is done. Okay, so if you're done, you can close star alignment. All right. If you want to see what your stuff looked like up here under Process Console, if you just mouse over it, it opens, and that's a scrollable window. But this is my last image, right? And this was actually the base image, and it didn't change anything. It didn't move. It didn't have to shift that image because it was already the images. Everything was going to be aligned to. It was the base image, and it just left it alone, and it moved it. But if I look up here, and I want to look at, say, the image prior to that, this one here, it rotated this. It didn't rotate the image, but it moved it 4.5 pixels one way and in the x-axis and 4 pixels in the y-axis. So, you can go back and look at this if you want, if you're really interested in that. I don't really typically care. I know it registered them. So we're going to stack that now. So we're going to go to Process Explorer again. And instead of image registration, we're going to select image integration. Okay, open that window up. And then down here, there's an app called Image Integration. Click there, double click that. All right. Image Integration, down right there, this right there, okay? And that's going to open up another window. And this is where you're going to put all your registered images. This is going to stack. So This is kind of like the stacking window, I guess that you could call it. They call it image integration. I call it stacking window. So if you want to put your files, you click on Add Files up here. And you're going to go to that directory that you sent all your files to. In my case, it's called Reg. In your case, it may be called something else. But the important thing is it's these files that are appended with this little R at the end. It means they've been registered. All right, I'm just going to select all of them. And I'm going to open. All right. Everybody there with that? Okay, so this gives you a couple different options of what you want to do with your data. It typically defaults to average, but it gives you options of median combining, min, max combine. Average is the thing you're going to use 99.9% of the time. Normalization is typically defaults to additive with scaling. Just leave that alone. Weights, it lists noise evaluation. Leave that alone. That's what you want. What it's going to do is it's going to look at the noise in each image because it remembers what the noise was when it did its statistics on the image, and it's going to pick the image that has the highest signal noise ratio as the base image to stack to when it goes to determine which one is my best one or my what's the word I want to use, my reference image, and I'm going to stack all the rest of them too, is going to be the one with the highest signal of noise, and that's what you want. That's one of the reasons why we went through and weeded out images that were bad, because we don't want to have those added into our stack of good data. All right, so they're all there. Now and leave the scale estimator at default. It works 99% of the time. There's lots of different options, but that's the one that typically works. You don't have to really worry about the others. If you are very interested in what the other ones do, by all means, read about it, mouse over, and look at it. The most important thing here is this rejection box, which is down here under rejection. This is the algorithm that's going to look at each one of those images and get rid of all the hot pixels, maybe the airplane meteor streaks through your image and so forth. So normally, this is very dependent upon how many images you have. If you got a whole bunch of images, typically, maybe say more than 10, Sigma Combine works wonderful. In this case, I don't think we had that many. We have like 6 or 7. So, well, I can use Sigma Combine. I mean, it should work. Typically, with just a few images, the best thing to use is percentile clipping. But for grins here, let's just pick Sigma Combine or Sigma clipping. All right. And does everybody have these defaulted as checked?
Yes.
Okay. So the last thing that you can do is down here under Pixel Rejection 2, window number 2. Here we are again back at our standard deviation values. So what this is going to do, it defaults to 3. Okay, so it's going to reject any pixel that's 3 standard deviations from the norm on the high side and 4 standard deviations from the norm on the low side. Normally, I just leave that stuff alone. If you want to get really picky about it, you can tweak those numbers. It allows you that flexibility, but the default works. And I think, that's all you have to do. So that should be good to go the way that is there. And what I want you to do is just click on the global button. And what it's going to do is it's going to look at the statistics of each image, and it's going to stack them all and get rid of all the good and bad pixels. Or keep the good pixels, get rid of the bad pixels. And this is where we're going to end up calling it quits for the day once this is done. Okay, did everybody complete that? Did it leave 3 windows open? All right, so what it gave you was it gave you a window of all the things it rejected, which is called rejection high. And if you remember the hotkey, Control A or Command A if you're on a Mac, if you do that, it'll stretch that window, and if you had bad pixels, they would show up in there. In this case, I don't think there was any streaks through any of those images, and we didn't have a whole lot of data in the big scheme of things, but yeah, I don't think you're going to see much there. But that's where you would see like your satellite trails and all that other stuff.
The radiation sign, what is that about? Below that window?
Oh, that's just, it's screen stretch, it's automatic screen stretch. It's the same as hitting Command A.
Oh,
So those windows it saves out. But your main image is called integration, okay? This is the one, this is your stacked image. And if you do a Control A on that, or Command A if you're on a Mac, it'll auto stretch, and that's your stacked data, okay? In this case, red, and yeah, so that's your stacked information. And hopefully it's rejected all the bad stuff. If you still see some stuff left over in it, like a streak through the image, probably you forgot, maybe you had one of the Sigma settings wrong or something. But normally it does a pretty good job. So normally, at this point, I go through my reds, greens, blues, luminance, and I create a stacked image for each one. But what it does is it names them all integration. So I want to save this as something else. So this little button right here, okay, set image identifier, the first thing I typically would do after I have this is I would change the name of that, okay? It's called image identifier. It's up here at the top of the screen right next to the forward and back arrows, all right?
red, call it red, activated red.
My naming convention is, I would call this mean red. And the funny thing with PixInsight, just to give you a hint, is you can't do that. You can't type in what you would think it would be, just mean red. You have to do mean underscore red. Okay? Always.
Or just mean. Yes. Where's the image identifier if they don't have their icons that you have?
Okay, well, it's normally.
But they don't have it because their screen's not as.
Ah, okay, okay. Yeah, so under image, identifier.
Does it happen to be underscored, or is there another way?
You have to put an underscore. If you have two words in there, the separator between those words has to be an underscore. You can't put a dash, it just won't work.
Can you do no space? Mean red?
Yes, yes, you can type all one word, yes. So you want to save that out as some other name is the point here. And I typically am going to call it mean red, all right? If I hit OK, if you notice up here, it changed it, all right? So the last thing I would want to do here is I would want to save this out. So I want to go File, Save As. And then it should default to mean red, and then I want to put it somewheres in a folder. And for me, the way I normally do it is I have a folder called Working. This where all my processing is going to happen from this point on. You may want to call it something else, but you want to save it to a folder, and you want to be able to remember where to go to get that, because this is where all your combined data is going to be, whatever you want to call the folder. And lastly, down here at the bottom, PixInsight defaults to a file extension called XISF. It does not default to .fit. like you're familiar with, FITS files. It changes the extension to XISF. And it does that because
In your working folder, you already have,
I do have stuff there already.
shall we make a different working folder?
You call it, yeah, you can, if you want to stick it in there, that's okay. If you,
I can just name it something else.
yeah, you can name it, because I've got a mean R in there already, which that's, we're going to use that tomorrow.
Create a different way.
But the point here is you want to save that file, because if your computer at this point crashes, you got to go through that whole process again to restack that image. So you want to save it out. All right? Okay?
If you don't choose image identifier, can't you just go file save as and name it right there?
You can, but it won't automatically come up with that name. Yeah, it's easier because if you work on that image later by doing other things within PixInsight, you automatically know that's my red image. Say you didn't close PixInsight. If you close PixInsight and reopen PixInsight and then open that particular image, it'll have a different name. But it won't have a different name if you don't close PixInsight.
Did you change your thoughts on the XISF option?
Nope, that's what you want to leave in there.
So you just said okay, right?
Yeah, just hit OK and it should save it out.
It has Adobe icons.
And once you do that, that's where we're stopping for the day. What we're going to do tomorrow is we're going to open up some already created masters that I have there under that working folder. I've got a master luminance, HA, red, green, and blue. And we're going to make a color image out of that and add in the HA data to it. And you know, those are the masters that are already waiting for us to mess with. So that's what we're going to do tomorrow.